Dear students, we are discussing exercise 13.1. Yesterday we discussed the limit of a trigonometric functions. Today we are going to discuss the limits of a general function, which is now the question 13 of this 23 of this exercise is find the limit x tends to 0 f of x and limit x tends to 1 f of x, where f of x is 2x plus 3 for all points which are less or equals to 0, and 3 into x plus 1 x greater than 0. Now we will discuss here two methods. The first method which we discussed earlier, we will find the value of the function at the points which are close to 0. Now the points close to 0 are of two types: those points which are slightly less, and points which are slightly greater. That is, if we consider the points which are less than 0 or slightly less than 0, or minus 0.01, minus 0.001, minus 0.0001. So there are infinitely many points. This means that we are approaching to 0 through negative side, that is x approaches to 0 negative, or x tends to 0 negative, that is this. Similarly, points close to 0 from right side, that is which are slightly greater than 0, or 0.01, 0.001, 0.0001, which means that we are approaching to we are approaching to 0 from right side, that is x tends to 0 positive. Now at the points, the value of the function is like at x equals to minus 0.01, the value of the function is f of minus 0.01. Here we have to substitute this minus 0.01 into x plus 3, because function is defined 2x plus 3 for all those points which are less or equals to 0, and this point minus 0.01 is less than this 0. That is why we have to replace x in 2x plus 3, which is 2.98. so this 2.98 is approximately equals to 3. Now similarly, at x equals to minus 0.001, f of minus 0.001 is 2 into minus 0.001 plus 3, because minus 0.001 is less than 0, so we have to replace x in 2x plus 3, and the value is 2.998, which is approximately equals to 3. Here this minus 0.01 is less than minus 0.001, so this means that when we are approaching to 0 from negative side, the value of this function, that is f of x, gets closer and closer to 3. That is, limit x tends to 0 negative implies f of x tends to 3. That is, this is the left limit. Similarly, at the points which are greater than 0, or x equals to 0.01, the value of the function is f of 0.01. But the function is defined by 3 into x plus 1 for all those points which are greater than 0. Here this 0.01 is greater than 0, so this means that its value is simply obtained by putting x equals to 0.01 in 3 into x plus 1, that is 3.01. Similarly, at x equals to 0.001, f of 0.001 is 3 into 0.001 plus 1, that is 3.003. Now this 3.03 is greater than 3.003, but here the point 0.001 is less than 0.01. So this means that when we approach, or when we get closer and closer to 0 from right side, the value gets closer and closer to 3. This means that x tends to 0 negative implies f of x tends to 3. This means that it is the right limit. Here left limit equals to right limit, so we can simply write limit exists. We can simply say that limit exists, that is limit x tends to 0, f of x is simply 3. That is, x tends to 0 implies f of x tends to 3. So this is one method which we discussed earlier. Now the second method is, which is actually the same, but this method, but the procedure is different. Now here x tends to 0 negative means we are taking the value of x close to 0 from right side, and there are infinitely many points, and all such points like minus 0.01, minus 0.001, minus 0.0001, these are all less than 0. So any point less than 0 and close to 0 is actually of the form of 0 minus h. 0 minus h, that is where h is slightly greater than 0. So this means that if we are asked to find the limit, right limit or left limit, that is limit x tends to a negative in f of x, this means that this simply means we are actually finding the value of the function at those points which are less than 0, or which are less than, sorry, here a. So this means actually we are asked to find limit h tends to 0 f of a minus h, where h is positive, Similarly, right limit means to find the value of the function at the points which are closer and closer to a from right side, or which are slightly greater than a. Now the slightly greater than a means x tends to a positive, and there are infinitely many such points which are greater than a, and all those points are of the form of a plus h. So this limit x tends to a positive in f of x actually means to find limit h tends to 0 f of a plus h. So we will discuss this procedure in finding limit of this function at x equals to 0. Like limit x tends to 0 negative f of x. This means that find the value of the function at all those points which are less than 0. Now the points less than 0 are 0 minus h, where h is slightly positive. That is limit h tends to 0 f of 0 minus h. Now f of 0 minus h is actually f of minus h. Now what is f of minus h? We know that f of x is 2x plus 3 for all those points which are less or equals to 0. Now here minus h is less than 0, so this means that we have to substitute h minus h in 2x plus 3. That is limit h tends to 0, 2 into minus h plus 3. Now 2 into minus h plus 3 is simply a polynomial in h. So how to find the limit of a polynomial at a point? By replacing the given variable. That is, we have to replace h by 0, that is 2 into minus 0, that is 0 plus 3, which is 3. Similarly, limit x tends to 0 positive f of means to check the value of the function at the points which are closer and closer to 0 from right hand side or from the positive side. So this means that we can write this as limit x h tends to 0 f of 0 plus h, because f of 0 plus h means when h tends to 0 means actually it is the right hand limit, now which is f of h. Now h is positive, so this means that we have to replace f of x as a h in 3 into x plus 1, that is 3 into h plus 1, which is polynomial. Its limit is by replacing h by 0, that is 3 into 0 plus 1, that is 3. Hence in both cases right limit equals left limit, hence we can simply say limit exists and limit x tends to 0 f of x is 3. Now at x equals to 1, limit x tends to 1 negative f of x actually means limit x h tends to 0 f of 1 minus h, where h is slightly positive or slightly greater than 0. Now here function is defined by 3 into x plus 1 for all those points which are greater than 0. This 1 minus h is greater than 0, so this means that we have to replace x by 1 minus h in 3 into x plus 1, that is 6, because this is a polynomial. Similarly, 1 positive, x tends to 1 positive f of x means limit h tends to 0 f of 1 plus h, that is limit h tends to 0 3 into 1 plus h plus 1, that is 6, which implies that left limit equals to right limit, hence limit exists and limit x tends to 1 f of x is 6. So in this way you can find the limit of a function at any point by this method. Now if we consider another question, find the limit x tends to 1 f of x, where f of x is defined by x square minus 1 when x is less or equals to 1, and minus x square minus 1 when x is greater than 1. Now firstly we will find the negative, this left limit, that is limit x tends to 1 negative f of x. This means that limit h tends to 0 f of 1 minus h. Now 1 minus h is less than 1. For all those points which are less than 1, f of x is defined by x square minus 1. That is limit h tends to 0 1 minus h square, because we have to replace x by 1 minus h in x square minus 1, that is 1 minus h square minus 1. Now this 1 minus h square minus 1 is a polynomial in h. So its limit is by replacing h by 0, that is 1 minus 0 square minus 1, that is 1 square minus 1, that is 0. So the left limit is 0. Similarly, right limit is limit x tends to 1 positive f of x is limit h tends to 0 f of 1 plus h. Here 1 plus h means the point which is greater than 1 because h is positive, slightly greater than 0. Now the function for all the points which are greater than 1, f of x is defined by minus x square minus 1. This means that we have to replace x by 1 plus h in minus x square minus 1 because the function is defined. That is limit h tends to 0 minus 1 plus h square minus 1. Now putting h equals to 0, so this means it is minus 1 square minus 1, that is minus 2. Hence right limit is minus 2, left limit is 0. So left limit not equals to right limit, hence we can say that limit does not exist at x equals to 1. Now if we consider the modulus function limit x tends to 0, f of x equals to f of x equals to mod x upon x when x not equals to 0 is 0 when x is 0. So we will find firstly the left limit, limit x tends to 0, negative f of x. Now this can be written as limit h tends to 0, f of 0 minus h, that is f of minus h. Now for all the points here h is not equals to 0, so this means that the function is defined by mod x upon x, that is limit h tends to 0 mod minus h upon minus h. Now mod of minus h is h and minus h is minus h, so when we cancel we simply get minus 1, and limit of a constant is simply a constant, means that minus 1. Similarly, limit x tends to 0 positive is limit h tends to 0 f of 0 plus h, that is limit h tends to 0 f of h, which implies that actually it is limit h tends to 0 mod h by h. The mod h is always h, which is h by h cancels, we get limit h tends to 0 1. Now it is constant, so its limit is the given constant, that is 1. So this means that for left limit is minus 1, right limit is 1, hence these two are not equal. So this means that limit at x equals to 0 of f of x does not exist because limit left limit is not equals to the right limit. So thank you.